Good morning, students. Today we are going to discuss about the random forest classifier implementation. So in the last class, we have discussed that how random forest works. We discussed that how random forest is different from the decision tree. So in today's class, we'll discuss that how we can implement random forest. So for the implementation of random forest, we are using here iris flower dataset. So this is very popular dataset which is consisting of different species or different types of flowers. So we have some 152 images, 152 rows are available in the data set, and the data set consisting of sepal length, sepal width, petal length, and petal width of the flowers. And using those information, using these four information, we are trying to predict that what type of species it is. So this particular data set is consisting of three species. One is setosa, another is versicolor, and third one is virginica. So we are trying to predict through random classifier that whatever species I'm giving, using the sepal length, sepal width, petal length, and petal width, it should identify which type of flower it is. So we are going to implement this. So first of all, what we are doing here, we are loading the data set and the required library for our implementation. So from the sklearn, we are importing the load iris. So this line of code we are using here. So it's not importing it's not loading the data. What it is doing, it is loading the module which is used for loading the data of iris. So first of all, we are importing the module which is required to load the data set, which is the name of the data set is iris. The second line of code it's showing here that we are importing the random forest classifier which is used for classification of the data. And the other libraries, suppose we are using here accuracy score, which is used for show the accuracy of the data, show the accuracy graph. We are using here this. And another library, you are already familiar here that we are importing pandas and alias of pandas as PD. So if I want to convert my data into the form of data frame, we are using pandas. Another one is, as we are working with the arrays, we have to import numpy. So this is the library which we have uploaded. Now in the next step, what we are doing here, we are generating a random number. So we have written here np.random.seed of 0. So I'm taking a random seed of 0. Why we are using 0? Because it's generating the random numbers. And what we are saying, whenever I execute this particular code, anytime it should generate the same random numbers every time. So it should not affect the accuracy. That's why we are keeping here seed value 0. So always it will generate the random numbers, and it will generate the same, it will reproduce the same random numbers which was produced first time. So it will not affect the accuracy of the model in every run. Fine. Now what we are doing here, we are creating, first of all, with this line of code, we are creating an object with the name iris. And what we are doing, whatever data set is available with us, we are keeping in the object which is iris. And now I want to print what is there in the iris. So when I'm executing this particular code, you can see the output. Okay, so you can see here output, what we are getting here. I'll scroll down just a second. See. So this is my data set which we are having. So my data set consisting of 4 features. If you remember, I told this particular iris data set is consisting of 4 features: sepal length, sepal width, petal length, and petal width. So this is whole data set which is available here. Okay. Now I have a target value also. Target value is, which is nothing but the label of the data. So it is a setosa, it's a versicolor, or it's a virginica. So target, this is target which is representing the target value of my data set. Okay, why we have written 0? 0 is representing here setosa, 1 is representing versicolor, and 2 is representing here virginica. Fine. And my data set consisting of 150 instance. Okay, the number of instances are in my data set is 50, and total 50 for each class. So this data set is well balanced because for every class we have 50 instance. So this is about the data set. If you want to see other information, you can go with the data set summary also. So you'll get the other information. Fine. So this, when we are executing the first line of code, we are getting this information about the data. Now suppose I want to print the first 5 line of my data set. Okay, so how my data set looks, I want to print that. So I'm using df.head. So first of all, what we have done before this, we have created one data frame df with the help of pd.data frame. And what I'm doing, the whatever features I'm having in my data set, I'm keeping in the form of column. So we are doing this one, and finally I'm printing the value of first 5 lines. Okay, so you just see here, it's representing the first 5 line of your data set. Sepal length, sepal width, petal length and petal width. Fine. Now, what I want to do here, as I have the features, but I don't have the target name of my features. So if my sepal length is this, sepal width is this, and petal width is this, what could be that particular species? So I want to keep the target also here. So I'm adding a new column with the name of species, and I'm keeping a target value. Okay. So what I'm doing here, I have created one new column with the name of species, and what I'm saying, it is a categorical kind of data because it is divided into categories. So I'm using categorical dot from codes. And where is my data? It is available in the target value. As you have seen the data earlier, the target values are available in iris.target, and I'm keeping those value into this. And now I want to print that value. You can see here, I'm printing the first 5 value, and I'm getting the species name also behind this. Okay, so we have all 4 features and corresponding species. Now this is just, we have loaded the data. Okay, we have loaded the data and we have created a data frame which is consisting of all 4 features plus the target value of those features. Now what I want to do, I have to divide my data into training and testing. So what I'm saying here, we are creating one new column with the name of is train. Okay, and I'm taking the whole data set and I'm considering the 75% data for the training. So you can see this code here. I'm creating a new column with the name of is train, and I'm using random. I'm using using random values, and it could random values. It will be either 0 or 1. And for how many times it will be? It will be for length of data frame should be less than 0.75. So if my length of data frame is less than 0.75, it will be true. Otherwise, it will be false. It means I'm taking 75% of the data for the training purpose. So when I've executed this particular line of code, you can see we have generated one new column with the name of is train. One new column has been generated with the name of is train, and a random value has been randomly 75% data is 75% data will be belongs to training, and other 25% data will belongs to testing purpose. Fine. So in that way, we have divided my data into training and testing. Now I'm creating a separate data frame for training as well as testing. So creating a data frame with test rows and the training rows. So what I'm doing here, train and test, I'm using two variables, train and test. Train will have this train variable will have the training data, and the test variable will have the test data. Now I want to see that how many, now I have divided my data into training and testing. Just for my sake, I want to see that how much values are there in the training and how much value are available in the testing. So you can see here the training data is consisting of 112 data points, and the testing data is consisting of 38 data points. So total we have 150, and 75% we have taken into training, so it is 112, and 25% we have taken for testing, it is 38. Fine. Now this is the division of the data into training and testing. Now what I'm doing, I'm creating a list of features names. So whatever features I'm having here, just I want to create a list of features for my purpose. It's not mandatory, just I want to see what are the features available in my data set. So just I'm using a one variable which is features, and I'm taking the columns from 0 to 4, means all the columns from 0 to 4. It means it will take column number, which column number? 0 means this is 0, this is 1, this is 2, and this is 3. So it will run 4 times, means 0 to 3. It will not consider 4, and I'm printing those features. So my features are sepal length, sepal width, petal length, and petal width. Okay. So this is not mandatory. So just to see what are the features I'm having, I want to check, then I can check in this way. Now, these features having the labels, and those labels cannot be readable by the machine. So I have to convert those labels in the form of machine readable. So I have to convert those labels, this TOSA and versicolor and all, I have to convert into the machine readable form. So what I'm doing, I'm converting into the digit. So what I have done, I'm using a target variable name y, and I'm factorizing my training of species data of 0. Okay, as it is an array of array, I have to use of 0 here. And when I'm executing this particular code, then we are getting a predicted value. We are getting the species name in the form of 0. So you can see here, this is representing, this is 0, this is 1, and this is 2. So 0 is representing here Setosa. Fine. So in that way, we have converted the species name into the machine readable form. Now my data is fully ready. Okay, I have a data, I have features, I have corresponding species. Those species we have converted into the machine readable form into 0, 1, 2. 0 is representing Setosa, 1 is representing versicolor. So in that way, we are having the representation of my data. Now I have to create my classifier. Now data is ready and now I'm giving the data to the classifier. So I'm using here random forest classifier. Okay, and I'm using n jobs equal to 2. So whenever you are executing this particular code in your local machine, you can use job value equal to 2. And if you are having a good computation power, you can use job value more than that also. And we are using random state equal to 0. As you know that random state we are using because every time it should take the same random value. So we have taken random state value as 0. So I have created a classifier with the name of CLF, and my classifier here is random forest classifier. Fine. Now I have created a random forest classifier. Now I want to train my random forest classifier. So whenever I'm training any classifier, I have to fit the model. So my classifier is represented by CLF and I'm fitting that classifier. So CLF dot fit on what data I'm fitting? On the training data. And Y is representing here what? Y is representing my predicted name, or Y is representing my label of the data. So I'm fitting my model on features as well as the species name, means input as well as on the output. Fine. So when I'll execute this particular line of code, I'll get the, it is 1 second, I'll execute it again. We'll see this later. So we are creating a random forest class. We have created a random forest classifier. Just a second, we'll execute from the beginning. I think there is a problem here. Okay, so this is executed. So we got the random forest classifier with n jobs equal to 2 and random state value we have kept as 0. Now I'm applying the I have trained my model. Okay, my random forest classifier is trained on the training data. Now I want to apply that on the test data. So what I'm doing, I'm trying to predict the value. So the same thing I'm applying on the test data. So you remember that we have divided data into training as well as on the testing. So I'm predicting my values on the test data also. So when I'm applying this on the test features, I'm getting so and so results. So it's my predicted output. Fine. Now I want to view the predicted probability of first 10 observations. So I want to see, this is the final outcome. Now I want to see the predicted probability of test features. Okay. So I want to, when I'm seeing the predicted probability of test features, when I'm executing this line of code, I'm getting the result in this way. So what it is showing, this is showing 1. So my first classifier, or we can say the first, as a random forest is consisting of multiple decision tree. So first tree is giving the decision that it is a Setosa. Other two are not giving vote for that. Other tree is saying 0, 0 for versicolor and 0 for the other species. So I am considering the first, so most of the predicted value I'm getting here 100. So it is showing the probability of my data. So the same way we have here also probability. So in that way you can check that what are the predicted probability of your observation, and the highest the probability of will take here voting system. So if two classifiers or two decision trees are giving the same result, we'll consider that as a final outcome. Fine. So this is my final outcome. Now I want to map the name of the plant for each predicted plant class. So I was getting 0, 1, 2 in that case. Now again I want to convert this 0, 1, 2 into the classes like Setosa, versicolor in that way. So if I want to map again to the species name, that what I have to do? Just again I'm using the predicted value equal to iris target names. My target names are available in iris target name, and for what I'm doing for this particular predicted value of test features. So I want to convert, or I want to map the name to name for the plants from 0 to that particular species name. For which values? For the first 5 values. So 0 to 5. So my first 5 values are saying that is all the plants are 0. So you can see here, this is their first prediction is what? We are getting all 0, 0, 0. So the 0 is converted into Setosa, or we can say 0 is mapped with the name of the plants. Now, I want to view the actual species for the first 5 observation. So I want to see that my observation is same as my actual value or not. My predicted value is same as the actual value or not. So I want to see. So just I'll take the first 5 test values. So test of species dot head. So my first 5 value is what? Setosa. And what my model is predicting? My model is also predicting Setosa. It means the prediction is correct. Okay, so my model is predicting Setosa as a Setosa, and I have 3 categories: Setosa, versicolor, and virginica. Fine. Now I want to create a confusion matrix. So you know what is exactly the confusion matrix here. So I am writing a confusion matrix which is consisting of actual prediction and predicted prediction for these 3 classes: Setosa, versicolors, and virginica. So it's representing here 3. So how many times Setosa is predicted as Setosa? 13 times. And how many times versicolor is predicted as versicolor? 5 times. Virginica is predicted as Virginica 12 times. So this is my true positive prediction. So in that way, I can create a confusion matrix for more than 2 classes also. So this is all about random forest classifier. So we have discussed about the random forest classifier here. We have taken the, I'll just conclude, we have taken the iris flower data set, and I made my data set ready to give to the random forest classifier. Then we have trained the random forest classifier, and finally we have test the random forest classifier to check the accuracy of my model. And finally, we have designed the confusion matrix to see the true positive and true negative value of my prediction. Fine. I hope it is clear to you. Thank you.